Hi, good morning, everybody, and once again, welcome to Pankaj's Echelon Tutorials. And in this today's session, we are going to continue with what where we had left last time. See, last time I had started with a new curriculum that is ISC, okay, and the subject that we selected was physics, and that was for the 11th grade. And the reference book that I told you I'm using is Kumar and Mittal. And I had started with the chapter 1, that is mathematics in physics. Okay, in the book, the name of the chapter is given as elementary mathematics. Okay, so that doesn't make any difference. Elementary mathematics. Okay, so in continuation, in the last video, okay, I had explained you many of the mathematical concepts which are used in physics. Okay, and I ended the previous lecture with with a derivative. Okay, so mathematics concept called derivative, how derivative is used in physics. Okay, so in extension to that, now I'll continue with this today's session. Okay, so today we are going to start with a new concept called concept of maxima and minima. This maxima and minima is what? Suppose you have a function y is equal to f of x. Okay. Suppose you have a function y is equal to f of x. And suppose the graph of that function is something like this. Now you can see in this graph, you have many, many low points and high points. Okay. So this point x2 and x4 are known as the minimum points. Okay. Or point of minima, you can say. And the same way this x1 and x3 are known as point of maxima. Okay, because this x1 and x3, at x1 and x3 you get peaks. Okay, so wherever you get peaks, okay, peaks, wherever you get peaks, those are known as maxima. And wherever you get what do you say, uh, like a trough like thing. Okay, now this is known as a trough, and this is known as a crest in physics. Okay, so wherever you get a trough, okay, those are known as minima. Okay, this is known as a minima, and wherever you get a crest, it is known as a maxima. Okay, now the other way of understanding in a layman's language is wherever you get a top of a mountain type of a structure. Okay, top of a mountain, so those are known as maxima. And if you get a bottom of the valley, okay, then those are known as minima. That way also you can understand, right? Now coming to mathematics. Now if you draw a tangent at these points where you have a maxima and minima, okay, if you draw tangents over there, you will see that these tangents, they are parallel to the x-axis. So obviously your dy by dx will be equal to 0 at these points. Okay, wherever you have drawn tangent at the crest and the trough. Okay, or you can say at the maxima and the minima. So these tangents that you have drawn are obviously, you can see from the graph, they are parallel to x-axis, and because they are parallel to x-axis, the slope of this tangents will be equal to 0. So what you have to do is, whatever this function f of x you have, that function you have to take and find out what is dy dx of that function. Okay, see, after this session, in this session itself, we'll be doing some numerical examples also. Okay, so in that you will understand how the application of this concept has been done. Okay, so first step is to find out find out dy by dx of this function f of x. Okay, and then you have to equate it to 0. When you equate it to 0, you will get some solution. It's an equation, so you will get some solution. And suppose you get the solution for x1, x2, x3, and x4. You will get x1, x2, x3, and x4, right? Now what you do is, again find out the second derivative. This is second derivative of f of x. Okay, second derivative means derivative of f of x, and again you find out the derivative of that derivative, that is known as second derivative. Okay, so second derivative of f of x you find out, and in the formula of that second derivative, you see first of all whether it is less than 0 or greater than 0. Okay, and if it is less than 0, okay, you have to find at x1. Okay, you have to find at these points, x1, x2, see, you will get the value of x1, x2, x3, and x4 on solving this dy by dx equal to 0. Once you get these values, then you find out d square y upon dx square, that is the second derivative of this function f of x. In that formula of that function, you plug in this value x1, and next time you put x2, next time you put x3, next time you put x4. So on putting the value of x1 in this formula, suppose you get the answer as negative, less than 0. That means at x1 you have a maxima. And suppose you get the answer as greater than 0 or positive, that will mean that there is a minima at x1. The same way at x2, x3 and x4 also you can find out whether there is a minima or a maxima. Okay. So this is the concept of maxima and minima, which will help you in determining at which point or at which values of x there is a minima or a maxima. Okay. So derivative, that is calculus, will help you in determining the maxima and the minima point as well. That was the concept of maxima and minima. Now let us try to understand the concept of indefinite and definite integration. Okay. Now here also, as I told you, when you do mathematics, okay, in detail, you'll be understanding the concepts, and will be a lot of problems also to get the real meaning and practice of these concepts. Okay. So here I am just trying to, bring to your notice that these are the mathematical concepts which are going to be used, okay, in physics, okay, every now and then. So you have to be very familiar with these concepts, right? Okay, so coming to the next concept is concept of indefinite and definite integration. Now integration is nothing but something called antiderivative. Okay, it is opposite of derivative. For example, suppose you have a function, say x is equal to 6. Okay, this you put it in a factory which is a derivative factory. Okay, or rather, in other words, if you say, if you find the derivative of this function x raised to 6, the answer will be 6x raised to 5. Okay, so this factory of derivative will convert this function x raised to 6 into 6x raised to 5. So this is your input and this is your output of your derivative factory. Now if you take this output and if you put it in this factory, which is integration factory, okay, so the output is 6x raised to 5. Suppose that 6x raised to 5 now you take as input and put it in another factory, which is an integration factory. Then the output of this integration factory will be nothing but x raised to 6. So this will be the output. So can you see, this input and this output both are one and the same? Okay. In short, what I want to say is, if you have a function f of x and if you find the derivative of that function, you will get some answer. That answer, if you integrate, okay, if you integrate that answer, okay, you will come back to the same input, okay, that is x raised to 6 in this case. Okay, so this is how derivative and integration are related to each other, you can say. So derivative is the output of a derivative factory, and that output, if you take as input of the integration factory, you will again get the input of the derivative factory. Okay, so it will get back to the same function x raised to 6. Okay, so this is all about integration. Suppose you have y is equal to, if y is equal to f of x, suppose this function is say x raised to n. Such functions are known as power functions. Okay, suppose you have a function like x raised to n. Okay, then integration of this x raised to n is written as integration f raised to x dot dx. This dot dx means you have to integrate the function f of x with respect to x. Okay, the answer will be given by this formula x raised to n plus 1 upon n plus 1 plus c. Now this plus c is always you will get when you are finding indefinite integration. This c is known as the integration constant. Integration constant. Okay, all this in detail you will study in mathematics. Now I just want to bring to your notice that these are the concepts which you should understand and master when you are starting with higher physics. Okay, now here I have given one example for this. Suppose we want to integrate a function of the form x raised to 5. Now this x raised to 5 is nothing but a power function with respect to dx. Okay, into dx means with respect to x. So the answer will be given by x raised to n plus 1, that is x raised to 6, divided by n plus 1, that is 6 plus c. So this is the answer for the integration of x raised to 5 with respect to x. You will get the answer as x raised to 6 upon 6 plus c. Okay. Then suppose you have y is equal to f of x equal to k, some constant k. Then the integration of that function will be equal to kx. For example, suppose you want to find the integration of 5. 5 is a constant with respect to x. So 5 into dx. The answer will be 5 into k, that is 5x. Same way, integration of 1 with respect to x will be equal to x. Okay. So these are the examples of integration. Now here there should always be a plus c also. Okay. Because integration constant will always be there. Okay. So that is about this indefinite integration. Okay. Now some more functions. I have given a table over here. These are the functions and these are the integration of those functions. Okay. So suppose the function is 1 by x. Okay. What will the integration of that function? The integration of that function will be log x. Now here you will understand one thing. Log x ka derivative, if you have this log x as a function and if you want to find the derivative, dy by dx, you know log x ka derivative is 1 by x, isn't it? Therefore, integration of 1 by x should be equal to log x to the base e. Okay. So that is how integration of 1 by x is log x to 1 to the base e. Plus that constant of integration will always be there. So this is derivative and this is integration. Okay. Now with the same logic, suppose you have a function as e raised to x. Now you know that e raised to x, the derivative of this e raised to x is same as e raised to x. Therefore the integration of e raised to x will also be e raised to x. So integration of e raised to x is e raised to x plus c. This constant of integration or integration constant will always be there. Okay. In indefinite integration, you will always get this c along with the answer. Now y is equal to secant square x. Now you know that tan x ka derivative we have seen in the earlier session. You know tan x ka derivative, I have shown you tan x ka derivative is secant square x. So this makes you say that secant square x ka integration is 10x. Okay. And that is why secant square x integration I have written as 10x. Now suppose y is a function which is constant. Suppose y is equal to 1. Then you know x ka derivative is 1. So 1 ka integration will be x. So it will be x plus c. Got it? Same way sin x ka derivative is cos x ka derivative is minus sin x. So sin x ka derivative will be minus cos x. And sin x ka derivative is cos x. So cos x ka integration will be sin x. Okay. So sin x integration is minus cos x. This is so because we know that cos x ka dy by dx is minus sin x, isn't it? So minus sin x ka integration will be minus cos x. Here also, because we know that sin x derivative is cos x, so cos x integration will be sin x. Okay. So that is how you have to find out the indefinite integration of some of the functions that I have mentioned over here. Now we come to next concept, which is known as concept of definite integration. Now what is this definite integration? Definite integration is just an extension of indefinite integration. Okay, so suppose I write an indefinite integration in this way. Okay, uh, suppose this is f of x dx is equal to f of x, right? So how I'll read this? I'll read this as integration or rather indefinite integration of a function f of x with respect to x is equal to f of x, a new function f of x, right? Now this is indefinite integration. Now if you put some limits over here, a and b, okay, so this integration is from a to b, right? Then this particular integration is now no more indefinite integration. Now it is known as definite integration. When you set the limits, it becomes definite integration. So here you will get f of x. Okay, when okay, I'll remove this a and b for now. I'll write it again. If it is definite integration, definite integration means there will be some limits set a to b. F of x dx will be equal to f of x a to b, and this is calculated as f of x for a minus f of x for b. Okay, this is something known as definite integration. It is just an extension of indefinite integration. So here I have shown you by example. Suppose this is the graph. Can you see this curve? This curve is a y is equal to f of x, say 5x cube. Okay, this is the graph of y is equal to 5x cube. Okay, now at these 2 points, okay, that is at this point and this point, that is x1 and x2, you are drawing vertical lines, right? So now what happens? The area under this graph and between the lines x1 and x2, that is y equal to x1 and x2, okay, sorry, x equal to x1 and x2, and the x-axis. So this area bounded under the curve between the x-axis and these two vertical lines at x1 and x2, this area will be given by the definite integration of this function. So how to find the definite integration of this 5x cube? I'll write this integration. Now since it is definite, I'll have to put the limits. Okay, so it is from x1 to x2. So niche I'll write x1 and here I'll write x2. So x1 to x2 f of x dx, this will be equal to whatever is the function, whatever is the integration of f of x, that will be this function, and that function I'll set a limit again x1 to x2. So in this case, suppose example is 1 2 3. Suppose this x1 is 1 and this x2 is 3. So I can write this integration 1 to 3 and the function is 5x cube with respect to x. So 5x cube ka integration is 5 into x raised to 4 upon 4, and this whole thing I will put again in a square bracket and I'll put this limits again 1 and 3. Now what I'll do in this function, okay, first I'll put the value for x as 3. So 5 into 3 raised to 4 upon 4. Then I'll put minus sign and I'll again take this 1 and plug it in x. So it will be 5 into 1 is to 4 upon 4. Now this, if you calculate, 5 by 4 is common out. 3 raised to 4 minus 1 raised to 4 is inside the bracket. This will give me 5 upon 4 times 80, which is equal to 100. So this is the definite integration ka value, okay, which I got as 100. So this 100 is representing what? It is telling me the area under the graph between the x-axis and bounded by these two vertical lines at x1 and x2. Okay, so this is how area under a curve you can find out using your definite integration ka concept. So these are some of the mathematical concepts which can be used in physics when you do higher physics. Okay, so you should be familiar with all these concepts. Okay, now once the concepts, the explanation and the theory part I have discussed, now today I'm going to end up this session by taking some 4 5 examples. Okay, and I'll try to make you understand how it works. Okay, so let us start with this example number 1. Now example number 1 says that y is equal to 3x square minus 5x plus 7. This is given to you. Okay, and the question is find dy by dx. So you have to find dy by dx. Okay, so this y is a function and this is a function of the form where you have certain terms, okay, which are connected by a plus or minus. Okay, so this is an algebraic function. So dy by dx of such functions is given by term wise. You have to find the derivative. To find the derivative, d by dx of 3x square minus find the derivative of this second term 5x plus find the derivative of this third term 7. This will give me derivative of 3x square is how much? This x square ka derivative will be this 3 you have to keep as it is, okay, into x square ka derivative will be 2 will come here and x raised to 2 minus 1, that is 1, so 2x. So this will give the answer for this. Minus what is the derivative of 5x? 5 is a constant, so keep it outside. X ka derivative is 1, so it will be 5 into 1 plus 7 is a constant, so derivative of a constant is 0. So my answer will be 3 to the 6x minus 5 plus 0. Okay. So 6x minus 5 is the answer for dy by dx. Okay. Let us go for example number 2. Example number 2 says that x is equal to 7 t raised to 5 minus 4 t square plus 3t plus 8. This is given. You have to find dx by dt and also find dx by dt. Okay, this is dt, not dx. Also find dx by dt when t is equal to 2. Okay, now this is the question. Now this type of question, how they will come in physics, that I will tell you. So this now appears to be a mathematical question where a function is given in this way. X is equal to 7 t raised to 5 minus 4 t square plus 3t plus 8. This is a function. You have to find out dx by dt. Okay. So to find out dx by dt, first let us do that. To find out dx by dt, what I'll do is I'll find the d by dt of 7t raised to 5, then minus d by dt of 4t square, then plus d by dt of next term is 3t, and then plus d by dt of 8. Okay, chalo. So derivative with respect to t of 7t raised to 5 will be, 7 is a constant, so I'll keep it outside. T raised to 5 ka derivative will be 5t raised to 4 minus 4 is a constant, so I'll keep outside, and t square ka derivative is 2t. Okay, plus 3t ka derivative, 3 I will keep constant out, and t ka derivative is 1. Okay, plus this 8 is a constant, so derivative of constant is 0. So I get 7 into 5, 35. 7 5s are, this is not 7.5, it's 7 into 5, right? So 7 5s are 35, t raised to 4 minus 4 2s are 8t plus 3 1s are 3. This is the dx by dt. Okay, so I have found what is dx by dt. Now they have asked you find dx by dt at t is equal to 2. So for this what you have to do is this dx by dt का जो formula है 35, in that for t you have to plug in the value as 2, so it will become 35. Now instead of t I'll write 2 raised to 4 minus 8, instead of t I'll write again 2 plus 3. So this works out to 2 into 2, 4 4 is 16 into 35 minus 16 plus 3. And if you work out this, I think you should get 547. Okay. So this is a mathematical approach. What you did is something mathematics. Okay. So a function was given to you. You found out the dx by dt of that function. Okay. And you got this as the answer. And that derivative ka at t equal to 2, you wanted to find out the value. So in that derivative ka function, for t, you are plugging in the value 2. So when you do that, you get 547 as the answer. Now, what is the significance of this in physics? Okay. Now, in physics, you know, this same question can be treated in this way. Now, suppose this x is the displacement. What is x? It is the displacement. And the displacement with respect to time का function is given here. This is the function f of t. Okay, one second. This can be written as x is a displacement function. Okay, uh, with respect to time t. Okay, so x is equal to f of t. This is the general form, right? So this x is equal to f of t, and this f of t is given as 7 t raised to 5 minus 4 t square plus 3t plus 8. Okay. So in physics, they will tell you that displacement function is given to you in the form of 7t raised to 5 minus 4t square plus 3t plus 8. Find the velocity. Okay, find the velocity function. Now, in the earlier session, I told you that velocity is nothing but differentiation of your displacement. Okay, so dx upon dt. Velocity is dx upon dt. So when you find out dx upon dt, which we found out here, this happens to be the velocity function. So velocity function is 35 t raised to 4 minus 8t plus 3. So the velocity ka general formula is this. Now suppose they ask you what is the velocity when time is 2 seconds. So this is the velocity ka formula. In this, you will have to find out dx upon dt when t is equal to 2. Okay. That means when t is 2 seconds, what will be the velocity? So what you will do, you will substitute this 2 for t in this formula, and you will find out the answer. And answer you will get as 547. So this 547, okay, is what? It is the uh, velocity, say meter per second, when the time is uh, 2 seconds. Okay, so after 2 seconds the velocity will become 547 meter per second. So this way, this physics and mathematics are going together, right? So this was mathematical approach. This is how it can be converted into physics, or how mathematics can be used in physics. Okay, so in physics we say that displacement is if displacement is represented by x, okay, and velocity, if you want to find out, then you have to do what? You have to find the derivative of the displacement function. Okay, so you have to find out dx upon dt to get the velocity function. And if you want to find out what is the velocity when a particular time t is given to you, then in that velocity formula, what you get, you put that value of t in that formula and find out the answer. That will be the velocity at that particular time. So here the answer is when t is equal to 2 seconds, the velocity of the whatever object it is, it will be 547 meter per second. I hope you are understanding these questions. That was example number 2. Now coming to example number 3, this is also a very good example. Okay, now here I am not going to tell you from the mathematical approach. I'm going to tell you from the physics approach. So the question is the velocity, I'll write that for you. The velocity of a moving particle, of course, if it is moving, then only it will have velocity. A moving particle varies with time. Fine, varies with time. Okay, as so velocity with respect to time is given to you, and it is given in the mathematical form. V is equal to, V stands for velocity, is equal to t cube. T stands for time. Okay, so t cube minus 2 root t plus a y. So this is a function. Now this function is nothing but v equal to f of t. Okay, this is that function. So velocity will be changing as the time keeps on changing, and the change will be according to this formula. So this is given to you. Now velocity is in meter per second. That also is given in the question. Now what he has asked is find the acceleration of the particle at t equal to 4 seconds. Okay. Here in this, velocity is in meter per second, that is given, and time is in seconds. This is given in the question, right? So don't bother about that. Find the acceleration of the particle. Now, in the previous session, I told you acceleration is derivative of velocity with respect to time, that is dv by dt. Okay, acceleration is dv by dt. So, d by dt of v, I can write it in this way. That is equal to d by dt, that is derivative of, now v is this function. Okay, so I'll write t cube minus 2 root t plus 1. Now to find out the derivative of this is an algebraic function. So I'll find out d by dt of t cube minus d by dt of 2 root t plus d by dt of 1. This is equal to t cube ka derivative is 3t square minus 2 root t ka derivative is 2 is constant to bring it outside, and derivative of root t is 1 upon 2 root t. Okay, this you can take it from me. Derivative of root t is 1 upon 2 root t plus derivative of 1, you know it is 0. So you get this 3t square minus this 2 gets cut, 1 upon root t. This is your acceleration function. Okay. So he has asked us to find the acceleration of the particle at t is equal to 4. So when t is equal to 4, what will be the acceleration? So acceleration when t is equal to 4 seconds will be how much? It will be 3 into, in place of t, you plug in the value as 4. So 4 square minus 1 upon square root of 4. This will work out to 4 square is 16, 16 3s are 48 minus 1 upon root of 4 is 2. So 48 minus half will be 47 and a half. This will be the acceleration, meter per second square. Okay. So this is your answer, 47 and a half or 47.5 meter per second square will be the acceleration of this particle. So now you can see that we have used derivatives, the concept of derivatives, although the problem was totally on physics. Okay, it was regarding velocity and acceleration of a particle, but we used physics and we used mathematics, the concept of derivative, to get the answer. Okay, let us go on to the next question, next example, and this example is example number 4, and this one says that the tangent at a point on the velocity time graph. So there is some velocity time graph given to you. Okay, let me try to, now suppose this is your velocity time graph. Okay, this is known as vt graph, right? Now this vt graph is given to you. The tangent at a point on the velocity time graph of a moving point makes an angle of 135 degree with the time axis. So with the time axis, suppose this graph is say, something like this. Okay. Now at this point, this is the tangent. Okay. So this tangent, okay, so just draw it properly. So this is that point. At this point, this is the tangent. Okay. So this tangent is making an angle of 135 degree with the time axis. This angle is 135 degree. Okay. This angle is known as theta, angle of inclination, right? So this is your y is equal to f of x. This is some graph. Okay. Okay. Can I write the answer question first for you? I'll write the question so that you'll understand. The tangent at a point on the velocity time graph, vt graph, of a moving particle makes an angle of 135 degree with the time axis. Okay. Determine the instantaneous acceleration at that point. Okay. Also indicate whether the velocity of the particle is increasing or decreasing at that point. So this is the question. Okay. Now let us interpret this question. So a graph of velocity time graph I have already drawn here. And suppose this is representing that function y is equal to f of x. This is the graph of a particle which is moving. So moving particle has this graph. And at a certain point, say this point, say P, okay, at this point P on the graph. So when the particle is moving, at some point P, okay, there is a tangent drawn, and that tangent makes an angle of 135 with the time axis. So this tangent I have drawn, this is the tangent. Okay, this tangent is making 135 degree with the t axis, that is the time axis. So this angle is known as the angle of inclination, and tan of theta will give you the slope of the graph. Okay, and one more thing you should know in physics, that the slope of a VT graph always gives you the acceleration. Now all this you will be studying in detail in physics, the subsequent chapters when you study in detail. This is just the mathematical concepts which are being used in physics. That is what I am trying to highlight over here. Okay. So in a velocity time graph, okay, whenever you find out the slope, that slope will tell you the acceleration. So this graph ka slope you can find out by using tan of theta is 135. So tan of 135 degree happens to be how much, you know? Tan of 135 is -1. Okay. Now this you can do it on calci also, or if you'll have to use trigonometry again to find out this tan of 135. Okay, I told you trigonometry also has a lot of application in physics. So tan of 135 degree is -1. So the slope of this tangent is -1. -1 is nothing but a negative slope because it has a negative side. So this is a negative slope, isn't it? Now, one more thing we know, that the slope of a VT graph will give you the acceleration. So your acceleration is equal to -1, and it is a negative acceleration. Okay. So the question was determine the instantaneous acceleration. So instantaneous acceleration that you needed is nothing but a is equal to -1, and the unit will be meter per second square. Okay. This is your acceleration, instantaneous acceleration. Instantaneous acceleration means acceleration at a given point. Which is that given point? That given point is this P, right? Now, they have asked you whether the velocity of the particle is increasing or decreasing at this point. So at this point P, you know that the instantaneous velocity is negative. Now negative acceleration, A negative, implies that the velocity is decreasing. Okay, so when velocity is decreasing, okay, the acceleration ka sign will be negative, and when the velocity is increasing, the acceleration will be positive. So whenever the acceleration ka value is positive, that implies that the velocity is increasing. Now, in this case, we see that the acceleration is having a negative sign. Therefore, what can you say about the velocity? Velocity is decreasing. So, therefore, the answer is velocity is decreasing. Okay, at this particular point. So, this is how we make use of derivatives, we make use of trigonometry, and all these simple mathematical concepts in physics. So that was example number 4. Now let us quickly do a couple of more examples, okay, so that we can wind up this session. Example number 5. Now the question says that uh, integrate, okay, 2 to 3 x dx. Now this appears to be a very straightforward mathematical question. Okay. Now if you want to do this, this is a definite integration ka question. So what I'll do is 2 to 3 x dx will be equal to, now what is the integration of x? Integration of x is x raised to 2 upon 2, isn't it? Okay. And then I'll put these values 2 and 3 over here. This will work out to x, I will put as 3. So 3 square upon 2 minus, now I'll put the value 2 instead of x. So it will be 2 square upon 2. This works out to 3 square is 9 upon 2 minus 2 square is 4 upon 2. This works out to 9 minus 5, 9 minus 4 is 5 upon 2. So this is the answer. Okay. So integration, the definite integration of this is 5 by 2. Now this is a straightforward mathematical question, but how they can ask you in physics? Suppose in physics they ask you the question, then or rather in mathematics only, I'll explain you this in a more detailed way. So suppose you have a graph like this. Sorry. Yeah. Uh, okay. Now, what is this function y is equal to x? So you know that y is equal to x is a straight line going this way. Okay, this is your graph. Y is equal to x. Now the 2 points given are 2 and 3. So this is 2 and then this is 3. And because this is a y is equal to x axis, this will also be 2. This will also be 3. Okay. Now it is definite integration from 2 to 3. That is from 2 to 3. This is the graph. So the area under this graph between the x-axis and the vertical lines at 2 and 3, this is the area which should be pi by 2, isn't it? Now can you see this is a trapezium? If you draw this figure separately, this happens to be a trapezium. This is 1 unit, 3 minus 2 1. This is 2 units and this is 3 units, isn't it? Now area of a trapezium is given by the formula half into sum of the parallel sides multiplied by the height. Okay, so this will be equal to half into sum of the parallel sides means 2 plus 3 is 5 into height means the distance between the parallel lines, that is 1. If you work out this, you will get 5 by 2. Okay, so area of this trapezium, if you do it by geometry, you get 5 by 2. If you do it by calculus, that is definite integration, you get again 5 by 2. Okay. So this is how you should understand the numericals. Now one more numerical we'll do to wind up our session. That is example number 6. It says that the acceleration of a particle, of course moving particle, is 2 meter per second square, right? The particle starts from rest. The particle starts from rest Okay, what will be what will be its velocity uh, at t is equal to 5 seconds. This is the question. Okay, now let us, this is a physics question, purely physics question. Let us use our mathematics. So acceleration of a particle is given, and we know mathematically acceleration is dv by dt. Okay, fine. So acceleration is given to you as 2 meter per second square, and derivative acceleration is also dv by dt. Now you know that when uh, derivative of v, here you can say derivative of v is a. Okay, that means integration of a with respect to time should be all should be equal to v, isn't it? Integration should be v, because derivative and integration are opposite to each other. Okay, so velocity ka derivative is acceleration. That means acceleration ka integration should be velocity, and that is what I have written. And here, if I put the value, because he has written the particle starts from rest, so here I'll put 0, and at t equal to 5, so here I'll put 5. Okay, so from 0 to 5, okay, time 0 to 5, acceleration, this is the formula that I'm going to use, right? Now we know that 0 to 5 acceleration is given as 2, isn't it? It is given 2, and dot dt, this will be my v. Fine. So what will be my v? So this 2 ka integration is 2t, and I'll put 0 to 5. This will be my v. Now this 2 into 5 first I'll take, minus 2 into 0 I'll take. This will be my v. So v will be basically 5 2s are 10, minus 2 zeros is 0, so 0 only, which is equal to 10. So this is my velocity in meter per second. So what is the velocity? The velocity at time t equal to 5 seconds is 10 meter per second. This is how you get the answer using your derivative ka concept. Now I'll make you understand this question in a very simple layman's language, like in the school you used to do it. Okay, the particle is starting from rest, so your velocity here is 0. Okay, it is starting from rest. Okay, and this particle, after every second, the acceleration is 2 meter per second square. The meaning is after 1 second, okay, the velocity becomes 2 meter. Then after second, when 2 second, the velocity will again increase from 2 to 4 meter. Then again after 2 seconds, it will become, again after 1 second, that is 3 seconds, it will become 6 meter. That way if you go, then, okay, I'll continue 6, that is after 3 seconds. Okay, and after 4 seconds, I'm continuing, after 4 seconds the velocity will become now 8, because the acceleration is 2 meter per second square. The meaning of this is for every second the velocity is increasing by 2. Okay, so velocity initially was 0. After the first second the velocity became 2 meter. After the second the velocity became 4 meter. After the third second it became 6 meter. After the fourth second it became 8 meter, and after the fifth second it will become how much? It has to become 10 meter. So after 5 seconds, when t is equal to 5, what is the velocity? Velocity is 10 meter per second. Got it? So this also explains you the uh, concept very well. So with this, I end this today's session, and I also completed this chapter number 1, or rather you can say the mathematical approach in physics. That particular topic I've covered. In the next session, I'll be starting with some other chapter, okay, in continuation, and perhaps that will be regarding some units and measurements. Okay, so that I will be starting in the next sessions. So thank you for being with me, and hope you enjoyed this lecture, this session of mine. So take care, all of you. See you. Bye for the next time.